So we're on chapter 2, section 3, and we're going to talk about both long and synthetic division. So first we are going to factor completely. So we're factor completely using long division. So other than the fact that the instructions said that we have to use long division, we could use synthetic division on this first problem, but the instructions said to use long division. So that's what we're going to do. The divisor is x minus 3. When we do long division, I'll get back to divisor in just a minute. We set it up with the divisor on the outside, and the first part that's before the division sign is the dividend, and that's what goes inside the division house. And we start all the way on the left. It's x. So we think x times what is going to give me this first term, 6x to the third. I like to think of the number part and the x part separately. So I have 1 times what gives me 6. Well, I need a 6. 1 times 6. And x times what gives me x to the third? It would be x squared, right? Because you add the exponents when you multiply. Okay. So I need 6x squared. I like to line up my powers of x. For this part, it doesn't really matter where you write that part of the quotient, but I like to keep them all in line. It's just a preference. So now I have 6x squared. I multiply it back times every piece of the divisor. So 6x squared times x gives me 6x to the third, and that's x to the third. So I'm going to put it underneath the other x to the third. This part is not a preference. This has to be underneath its like piece. You have to line up these. So that's why I just go ahead and line up the top part also, and then I don't have to remember which ones I have to and which ones I don't. 6x squared times negative 3, because I have to multiply it by each piece of the divisor, gives me negative 18x squared. All right, so there we go. Then I'm going to group it in a set of parentheses so I can subtract. I know Miss Moore has a little phrase that she says, change the sign and draw the line, where she changes the sign of each part and then draws a line, which is the same thing I would do if I distributed my negative into the parentheses. It's going to change the sign of each term. They will both get you the same result. Whichever one you like better, that's one you should do. 6x to the third minus 6x to the third. That cancels out. That's the whole idea of what I wanted to happen. If it didn't cancel, then go back because you made a mistake. Negative 25x squared minus negative 18x squared. So it's 25 plus 18, negative 25 plus 18. So it's going to give me negative 7. And those are x squareds. And then bring down anything else that you haven't worked with yet. So I'm going to bring down the plus 18x plus 9. And then I start my whole process over again. Come back out here to the left side, the x. X times what is going to be negative 7x squared. Well, I need a negative 7, and I need one more x, one more power of x. So negative 7x. Put it on the top. Negative 7x multiplied by everything in the divisor. Negative 7x times x is negative 7x squared. Negative 7x times negative 3 is positive 21x. Then group it so I can subtract and draw the line, or draw the line and change the sign, whichever method you like. Or negative 7x squared plus 7x squared cancels. Positive 18x minus 21x gives me negative 3x. bring down anything else you have left over or that you haven't dealt with yet. So I'm bringing down the positive 9. And then I start my process over again. Go back to the x in the divisor, the x minus 3. X times what gives me negative 3x. Well, I would need negative 3. Then multiply by everything in the divisor. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Group it so I can subtract. Negative 3x plus 3x cancels. 9 minus 9 cancels. So I have 0 as my remainder. I always put my remainder in a box as a signal to myself that I'm finished and that is the remainder. All right, so again, look back at the instructions. It says factor completely using long division. Well, I used long division. I took the polynomial, I divided it by x minus 3, and it gave me, the quotient is what's here on the top. But that quotient is not fully factored. It says factor completely. That's a quadratic. That's x squared. So I can take it to the side, 6x squared minus 7x minus 3. And I can factor that further. So if I'm factoring completely, I need to factor it all the way down to linear factors. So I'm going to use the a times c, the add up to equal b method, a, c, b method. A is 6, c is negative 3, so 6 times negative 3 is negative 18, and I want it to add up to equal the b value of negative 7. So I think if my factors of 18, well, 9 times 2 gives me 18, and if I make that 9 negative, it would be negative 9 plus 2. That's negative 7. So negative 9 and positive 2 are going to go in the parentheses with the x. So x minus 9, x plus 2. And then I have an a value that is not 1. So my a value is 6. So I need to divide each of these by 6. Well, 9 does not divide evenly by 6, but they do have a common factor of 3, so I could divide them each by 3. I could reduce the fraction. 9 divided by 3 is 3. 6 divided by 3 is 2. And that would make this one x minus 3 halves. And then the other factor, 2 does not divide by 6, but I can divide it by 2, and it would give me a 1. I could divide the 6 by 2, and it would give me a 3. So this factor would be x plus 1/3. But I'm not finished factoring because you're not supposed to have fractions when you're factoring. I use the phrase bottoms up with the 2, or bottoms up with the denominator. I just take what's on the bottom and move it up in front of the x. Take what's on the bottom, move it up in front of the x. So this factor is 2x minus 3, and this factor is 3x plus 1. So now I factored the quotient, and then I have another factor, because when I divided I had a remainder of 0, so that means I have another factor, so I can write my answer, f of x equals the function equals the divisor, x minus 3, times the factors of the quotient, 2x minus 3 and 3x plus 1. So there I completely factored my 6x to the third minus 25x squared plus 18x plus 9. So this part came over here. And I'm going to highlight this x minus 3 because oftentimes that part is left out of the answer. because you take the quotient over to the side to factor it once it's down to a quadratic. And then you just write that as your answer, but that's not just the answer. If you multiplied this back together, it would not give me the starting polynomial. You have to also multiply it by what you divided by. So don't forget, that is also part of your answer. So I have 3 factors. All right. One more example of long division. And I'm going to use a lot of vocabulary in this one. So once I've finished going through the example, I'm going to go back and I'm going to label all of the vocabulary. All right, so again, the divisor is a commonly left out part, so I'm going to highlight that. The divisor, it's what you're dividing by. It's also out here. It's important. So the difference on this one is you're written in division in a numerator over divided by denominator format, where the last one was written with the division symbol. It's the same thing. Your divisor is in the denominator. What you're dividing is in the numerator. It's the dividend. It's what you're dividing. So you just take the numerator, put it inside the division house, take the denominator, put it on the outside. And then you start this the same way. And this one looks like it's going to be worse because your divisor has 3 terms instead of just 2. But really when this happens, you end up doing less work. So it looks like it's going to be worse, but really it's a nicer problem. So I'm going to start the same way. I have x squared, and so I'm thinking x squared times what is going to give me 2x to the 4th? Well, I need a 2 and an x squared. So 2x squared. Just for the habit, I'm going to go ahead and put it over the x squared. You can put it wherever you like, but I like to keep mine lined up. So then I have 2x squared, and I have to multiply it by every piece of the divisor. So I'm going to multiply 3 times because there's 3 terms in the divisor. So 2x squared times x squared gives me 4x to the, 2x squared times x squared gives me 2x to the 4th. Put my number in the wrong spot when I said it. Gives me 2x to the 4th. 2x squared times negative 2x is going to give me negative 4x to the 3rd. 2x squared times positive 7 is going to be positive 14x squared. And all of my powers of x are lined up in columns. So just make sure it's nice and neat, and your powers of x are all in a nice neat column. Then I am going to parentheses subtract or change the sign and draw the line, whichever way you like to think about that. 2x to the 4th minus 2x to the 4th. Perfect. It goes away. That's what I wanted to happen. Negative 4x to the 3rd minus negative 4x to the 3rd. So that's plus 4x to the 3rd. Those canceled also. That's just a nice bonus that they canceled out also. 13x squared minus 14x squared gives me negative 1x squared. You can write the 1 or not write the 1. It doesn't matter. Whichever you like to do. And then bring down any leftover terms. So plus 3x minus 11. And then you start the process over again. You come back out to the far left. X squared. X squared times what gives me negative x squared? A negative 1. You can put your negative 1 wherever, you can put it right up next to the 2x squared if you want, but I like to keep them all in a line. So I have negative 1 times negative x squared is negative x squared. I have negative 1 times negative 2x, so that's positive 2x. Negative 1 times positive 7 gives me negative 7. I'm going to group it and subtract, or change the sign and draw the line. Negative x squared plus x squared cancels. Positive 3x minus 2x gives me an x. Negative 11 plus 7 gives me a negative 4. I know I'm finished dividing when the power of the divisor is greater than the power of what I'm trying to divide. So that means this is my remainder. So I'm going to put it in a box so I know it's my remainder. Okay, so now I'm going to write my answer. It said factor completely. I can't factor anymore because I have a remainder that didn't actually factor. So this is the best I could do. So I'm going to write my answer, and then I'm going to give you label all of those words that I'm about to use. So the function is going to be the divisor, x squared minus 2x plus 7, because that's what I divided it by, times the quotient, which is on top, 2x squared minus 1, plus the remainder, x minus 4, divided by the divisor, because I didn't divide the x minus 4, I had to stop. So x squared minus 2x plus 7. Because that one didn't divide evenly. So that's as much as I could do as far as factoring goes, because it did not factor. All right, so now to label all of these vocabulary words. We have divisor. This is the divisor. This is the divisor. We have quotient. It's what's on top after we divide. What we divided, what's inside the division house, that's the dividend. What's left over after dividing is the remainder. So our answer, so this whole, everything in the box is the answer, but the answer is made up of, so I can write this as f of x equals the divisor times the quotient plus remainder over divisor. Which is this part here. So these vocabulary words are going to be very important once I give you a test, because you will also need to read the question and make sure you're answering the question that I ask. I might just ask you what the quotient is. If I just ask what the quotient is, that doesn't mean to give me this full answer. The quotient is just 2x squared minus 1. So if you were to give me all of this, that's not answering what I asked. If I just ask for the remainder, then the remainder is just x minus 4. So you would just answer x minus 4. You would not answer all of this. If I could give you this and ask for the divisor, and then just give me the divisor. And you wouldn't have had to have done any work, just write down the divisor. So pay attention to the vocabulary. It is important. These are the same vocabulary words that they taught you in elementary whenever they first taught you how to divide. Yes, I understand that was a long time ago. That's why I wrote them all down and labeled everything. Stop that video.